Hello students, I'm Dr. Tanmoy Biswas. I welcome you all in my YouTube channel and Facebook page. Today we shall discuss a very interesting MCQ, that is what is the major product of these reactions. So this is actually a non-conjugated diene reacts with m-CPBA. What is the product? Before going to the details, let's learn a little bit about this m-CPBA or meta-chloroperoxybenzoic acid. Why perbenzoic acid? Because there is actually a peroxy linkage. So this is a peroxycarboxylic acid and it is widely used as oxidant in organic synthesis. Why this is acting as oxidant? Because these two oxygens are in -1 oxidation state, which is actually the intermediate oxidation state of oxygen, and generally peroxide shows as oxidizing behavior. That's why it oxidizes other. So it can oxidize electron rich alkene. This is very interesting. If you look at the question, there are two types of double bond present. Now, between them, it will oxidize the electron-rich alkene to corresponding epoxide. Now, let's understand which double bond is actually more electron-rich and why. If you look at this side CH3, this side CH3. So, if you look at this double bond 1, it is tetra-substituted 1, 2, 3 and 4. So, this tetra-substituted alkene is more reactive. What do I mean? Because this case 4 plus I and here 3 plus 3 6, 6 plus 4 10 hyperconjugation possible. Because of that, this alkene is more electron rich, and as I told that it can oxidize electron rich alkene to corresponding epoxide. So obviously epoxidation at this position is preferred over here, because if you look at this double bond number 2, it has only 4 hyperconjugation and 2 plus IFX. So obviously it is comparatively electron deficient than this number 1. Okay. So m-CPBA preferentially oxidizes the more electron rich. By the way, there is another one reagent which can oxidize less electron rich or electron deficient alkene, that is hydrogen peroxide, sodium hydroxide. I shall provide the link in the description box. Now, so this much we understand. Now your question will be, sir, hyperconjugation or inductive effect, it stabilizes the alkene, but do you think it will make the molecule reactive? Answer, yes. It's a very interesting concept that more reactive substance is also more stable. So please read this video, very interesting concept. I shall provide the link in the I button and description box. Now let's go back to our answer. So this part will be oxidized, so that's why option B is the right answer. Now you think, sir, C and D, what do I think? Because if you look at this case, this versus this, really logical. Now it's an epoxide, so this carbon is oxidized, this carbon is oxidized. Now if you think, sir, I want to break this epoxide 3-member ring strain, so by the way, the medium does not support that. One thing I agree. Still, if you have any doubt, just look at here. I should expect 2OH, but is it given in the question? So question is telling you that, okay, which one should be the right answer? Very easy question. So if you know the concept and little bit common sense, that's that. This is also not. So this is gone. So this actually options D and C, this is really illogical. 1OH is not possible. Okay, and if you think this side, it is not possible for m-CPBA because it's comparatively less electron rich, and m-CPBA prefers more electron rich this one. So obviously option B is the right answer. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.